Let's take a look at topic 4, review operational polynomials. So in this class, we will use a lot of this frequently, operational polynomials, add them, subtract them, multiply, and divide them. But I don't think I'm going to introduce division here. We will do division later on the semester. So what is a polynomial? As you can recall, a polynomial is simply something made out of many unlike terms. What is special about them is polynomial has many unlike terms, but they all have the same variable. They are unlike terms because all the exponents are different. Okay, so this is a generic form for a polynomial. I want you to see this now because later on the semester I will bring this back. So polynomial p using the variable x is what px stands for. Okay, polynomial using variable x can be expressed as a to the n, x to the n power plus a to the n minus 1, a to the n minus 1 power, so on and so forth. So what you notice here is the exponent is dropping plus x of 2, x to the second power, then x of 1, x to the first power, and x of null. So x of null, the last term does not have a variable because technically x of null is a to x of null times x to the 0 power. Oops. Anything to the 0 power is 1. So that's the reason why the last term you don't never see an x. So the last term of a polynomial is what we call the constant term. Okay. So what you notice here is the exponent is always decreased by 1. A of n minus 1 was in front of the x. We can call them coefficients. So all the coefficients are different. Exponent is expressed as in descending order. So here, perfect example. This is a perfect example of a polynomial. 2 to the x to the third plus x to the second minus x plus 4. So this 4 is actually 4x to the 0 power. So anything to the 0 power is 1. 1 times 4 is still 4. That's the reason why the 4 here is actually going to be a constant term. So polynomial will always be expressed as in descending or ascending order on the exponents. Okay, gotta be in order. Got it. And 9 out of 10 times it's gonna be in descending order on the exponents. What is so-called the degree of the polynomial is referring to as the highest exponent of a non-zero term in the polynomial. So the highest exponent that you see here is third power. So the degree of the polynomial is 3. Okay. So it's very important to identify the degree of polynomial because that term, if degree is 3, that means that term should be your first term, or we call them as leading term. Okay, leading term will always be the term that contains the highest exponent. So, for example, 6x to the fifth plus 4x to the seventh plus x squared plus 2x to the third. Here, the degree, and normally degree we call them n. Okay, degree of polynomial we express as n. Degree is 7, so this term should be the leading term. So that means that term should be the first term you write. So let's put this in order. So 4x to the 7 should be first. The next one will be positive 6x to the fifth power, right? Exponent go down in order. Excuse me, exponent go in descending orders. Then 2x to the third power should be the next term. And positive x squared should be the next term. All right. So just kind of refresh your memory on this. Degree of polynomial is the highest exponent of a non-zero term in a polynomial. And I'm sure you probably heard all these before: a monomial, binomial, trinomial, polynomial. But these are very specific. Okay, these are specific wordings for very specific type of problem. A monomial is a polynomial with only one term. Well, that one term is not referring to as the constant term. It does not referring to, hey, here I can just write a 4 and that's a polynomial. It's not what's a 4. We don't quite use it like that. A monomial is really referring to a polynomial only have one term, and that one term is normally going to be the leading term because that's the only term it has. So it normally carries some sort of exponent with it. Okay. So technically, there are other terms behind it. We don't see them because they all have coefficient 0. And those are considered as missing terms. Missing term, they are missing because all their coefficients are 0. That's the reason why this is a monomial. You can just write one term because all the term behind it is all zeros. All right, binomial. Binomial is used for very specific time when we multiplying. Binomial normally means is a polynomial with two terms, but we use the word binomial whenever we multiply. Okay, whenever we encounter two terms times two terms, we will say this is a binomial times a binomial. Trinomial is a very specific wording in my class. Trinomial is not just three terms. What is considered as a true trinomial. A true trinomial, oh Lord, spelled it wrong, is referring to as the last three terms of a polynomial with exponents 2, 1, 0 power. You cannot just have any three terms and call them a trinomial. Okay, this wording trinomial is used for very specific type of problem. So what is considered as a true trinomial is the last three terms of a polynomial with the exponent 2, 1, 0. So if you look back at this form, the last three terms is the true trinomial, where their exponents are 2 power, 1 power, and 0 power. Okay, those are true trinomial. So my example here, x squared plus 2x plus 1 will be a true trinomial. All right, polynomial, of course, polynomial is polynomial with many, many terms. So let's use those. So let's use some of these wordings when it comes to in here in a minute when we multiply and such. Operations of polynomial, add and subtract. Let's do add and subtract. So we can add and subtract using horizontally or vertically. There are two main ways to write them out. But I normally just show students how to do it horizontally. So when we do it horizontally, we're just gonna use things we already know. Distribution, bring the terms to the outside the parenthesis, and combine like terms. So when it comes to add and subtract polynomials, it is just like combine like terms. So remember, when we combine like terms, we will only add or subtract the coefficient and do nothing with the exponent. Remember, we're not doing so many x times so many x. Okay, we're not multiplying. Multiplying tells me to add the exponent. But when it comes to combine like terms, all I do is add and subtract the coefficient, and we do nothing with the exponent. The exponent should still be whatever they are, because the exponents is what I use to identify who are the like terms for me to combine. So you cannot have a 1x plus 1x become 2x squared. That just does not make any sense. All right, so be very careful, okay? So addition of polynomials. So the parenthesis simply indicating this is one polynomial plus another polynomial. But since I have a plus sign here outside the parenthesis, what's in front of it should be my first term. And what's behind it should be my second term. And the plus sign go with the second term. All right, so I know my second term, there's no number here. So I know I need to use positive 1, do a distribution. My first term, there's no number in front of it. So it got to be another positive 1 here for me to do distribution. So 1 times all 3 terms inside, nothing changed. Still 7x squared, positive 5x, negative 8. Positive 1 distribute again should be positive 3x squared, positive ax, and negative 9. Combine like terms, so degree of the polynomial is 2. The highest exponent is 2, so those terms should be combined first. 7x squared plus 3x squared should give me 10x squared. X to the first go next. 5x squared plus ax squared, positive 13x. Excuse me, 5x plus ax is 13x. Negative 8 minus 9. Term with the same sign we add. That should be negative 17. Okay, so that's all it is. Subtraction, just gotta be careful, okay? Same technique, distribution. It's just my second term now. I will use a negative 1 do a distribution. My first term, still a positive 1. If there's no sign in the front, that's a positive 1 distribute. So that would be 7x squared plus 5x minus 8. Negative 1 distribute. Negative 1 times 3x squared is negative 3x squared. Negative 1 times positive ax, negative ax. Be careful. Negative 1 times negative 9, positive 9. All right. So once I distribute, combine like terms. Degree is 2 still. So 7x squared minus 3x squared go first. That will give me 4x squared. 5x minus ax. Term with different sign, we will subtract. So that should give me negative 3x. Negative 8 plus 9. Term with different sign, I subtract. That should be a positive 1. Okay. So distribution is probably the safest technique that we can use. Bring all the terms to the outside, make sure all the signs are correct, then combine like terms. Let's take a look at multiplication of polynomials. So when multiply polynomials, okay, so this is multiplication now. We will multiply the coefficient and add the exponent. So normally when we multiply polynomials, we just say it. We don't actually write them all down. So if you actually Google this or look at other websites, they will write all kinds of crazy stuff for you. They are writing too much detail on the main part of your work. So if you need me to write it out, I can. But multiplication of polynomial is just like a distribution. Basically, we're gonna take since I got 2 terms in the first parenthesis, I will take the first term and I will multiply or I will distribute all the terms in the second parenthesis. So when the first 3x, the 3x will times the 2x squared, negative x, and the positive 3. So when the 3x times the 2x squared, the 3x times 2x squared, 3 times 2 is 6, x to the first times x to the second is x to the third. So we don't want constantly writing this out. So normally people just say it, and when they say it, their mind is thinking multiply the coefficient and add the exponents. Okay, that's what the mind is actually doing. So 3x times 2x squared should be 6x to the third, right? 1 plus 2 is 3. 3x times negative ax is negative 24. X to the what power? Second power, right? 1 plus 1. 3x times positive 3, positive 9x. So that's 3x multiplying. So now, second term in the first parenthesis, negative 2 will also multiply all 3 terms. Negative 2 times 2x, negative 4x squared. Negative 2 times negative ax, positive 16x. Negative 2 times positive 3, negative 6. So 2 term times 3 terms, you should have 6 terms coming out. And then we just combine like terms. So the degree here got to be 3. So that term go first. Square term go next. Negative 24x squared minus 4 more x squared. Negative 28x squared. X to the first power, 9 plus 16. Is that 25? Positive 25x. All right, negative 6 has nobody combined with, so that will still be negative 6. So that will be my answer. Multiplying the polynomial. We'll do this quite a bit. Special product. Special product is very important. Whenever we got 2 term times 2 terms, so binomial times binomial, we always think of this thing called FOIL method. FOIL method is actually a special product. It's designed to be like a shortcut. Okay. Okay. So FOIL method is used when there are, when there are 2 term times 2 terms. The F stand for first, outer, inner, and last. So let me do this example, and I'm gonna also write the same problem here on the side. So FOIL method is just like multiplication of polynomials. The 2x, you got 2 term in the first parenthesis. So this 2x will need to do a distribution. So when you write it out, it's really saying the 2x will now times 3x minus 4. Then the positive 3 will also times the 3x minus 4. That's what it really is. So instead of writing like this, we can just say first thing you do is 2x times 3x. That's first. And 2x times 3x is 6x. What is it? 6x what? Square, right? X plus x times x is x squared. The next thing you do is 2x times negative 4. So when you do 2x times negative 4, that would be your outer. That would be negative ax. 2x times negative 4, negative ax. Then the next thing you do, once the 2x finishes distributing, then it's positive 3 will do a distribution. So positive 3 times 3x, that will give me positive 9x, and that will be called the inner. And the last thing you do will be positive 3 times negative 4, and we call that the last, negative 12. So the degree is 2, so combined like terms, I should have 6x squared minus x, right? Negative 8x plus 9x is negative 1x minus 12. So this answer, whenever you got 2 term times 2 term like these, okay, your answer will actually come out to be a true trinomial. And this true trinomial answer, the middle term of your true trinomial answer always come from the inner and outer combined. Well, negative x come from negative ax plus 9x. Negative ax is your outer. Positive 9x was my inner. So the middle term of my true trinomial, once I multiplied, is my inner and outer combined. Because when we factor the trinomial, we will actually do this problem backwards. So that's the reason why it's good to know the middle term comes from the inner and outer combined. All right. Difference of squares, very important. Difference of squares is very important special product. Again, binomial times binomial, 2 term times 2 terms. So what's unique about them is the first term in both parentheses are the same. The second term in both parentheses are the same. It's just one is positive, one is negative. So what's going to happen is your inner and your outer will be exactly the same answer, exactly the same number, but having opposite signs. So your middle term, your inner and outer will actually cancel each other out. Therefore, your answer would just be your first term squared minus your second term squared. A squared minus B squared is equal to A plus B times A minus B. Spatial product. So for example, right here, 2A, 2A, right? 3 and 3, one positive, one negative. So right away, you see that this is a difference of squares. So all we got to do is saying my A in my formula, my A is my first term, right? My first term, whole thing squared. 2A whole thing squared should be 4A squared. So what I just said is 2A whole thing squared. That's a power rule. Minus my B is 3, right? And formula calls for A squared minus B squared. So my B got to be squared. So my 3 got to be squared. So that will give me 9. So that's all it is. Okay. So once you recognize that this is a difference of squares, so then you take your A or your first term, whole thing squared, minus your second term, whole thing squared. That's all it is. All right. Perfect square binomial. Some people call this a perfect square trinomial. Perfect square binomial is basically saying if I have A plus B whole thing squared, like I mentioned in the previous topic, because there are two terms inside the parenthesis, I cannot apply my power rule. So instead, what we do is if you have two terms in the parenthesis, whole thing squared, all you do is by saying my base, my entire base, A plus B, is technically multiply each other 2 times. So perfect square binomial is basically look just like difference of square, except difference of square, one is positive, one is negative. Perfect square binomial, the signs in the two parentheses are always the same. So your middle term will never cancel out. As a matter of fact, if I use FOIL method, A times A is A squared, A times B positive AB, inner is B times A positive AB again. B times A is the same as A times B. Okay, that will be the commutative property that we mentioned before. B times A, you can write AB. Positive B times positive B squared. So what you notice here is the two middle term, inner and outer, are exactly the same. So that's the reason why you end up with 2AB in the middle. So again, special product are meant to be done just by looking at it. If not, that's okay, but we can practice. If you're not, you can write them out as 5x minus 3 times 5x minus 3 and forward out. But while we're in class, we can practice this, okay? Just use a formula. Your just let me write down the minus version right here. A minus B squared is equal to your A squared minus 2AB plus your B squared. So we're matching up 5x with the A, 3 with the B. So the formula called for your A got to be squared. My A, 5x got to be squared. So that means 5x squared. So that will give me 25x squared minus 2 times my A times my B. 2 times my A times my B. 2 times 5x is 10x. 10x times 3 is 30x. Plus my B3 got to be squared. That will be 9. So that's your answer. Let me give you an example. This is 3 term times 3 term. We're going to run into this example later on the semester. This problem, we can forward it out. Okay, we can multiply it out like we multiply polynomial, or we can look at it as difference of squares. That's why I need you to recognize the difference of squares. your A plus your B times your A minus your B. So if you can recognize this as difference of square, then difference of square tells you that your A being two terms, whole thing squared. Now we'll minus your B, 3i, whole thing squared. A squared minus B squared. So now this part becomes a perfect square binomial where we can use the formula. Okay, so we will run into this later on the semester. I will refresh your memory. So that's real quick on reviewing perfect square binomial, your difference of squares, for your methods, multiplying polynomials, and of course add and subtract polynomials. All right, so let's go over this real quick. What is made of the many unlike term with the same variable but different exponents? A polynomial, right? Degree of polynomial is the highest. Go ahead and copy down right here. Degree of polynomial is the highest exponent of a non-zero term in the polynomial. What is a true trinomial? Into the definition. All right, so it's right here. A true trinomial. A true trinomial is the last three terms of a polynomial with exponent that says 2, 1, 0 power. That would be question 3. All right. Look at this problem. Select which one of the three special product you will use. It's the best to describe this problem. Same thing with question number 5. All right, question number 6. Okay. Number 1, multiply the polynomial. So 2x will distribute, right? And then -3 will distribute. 2 times 3, you should have 6 terms. You should have 6 terms coming out. Don't combine like term yet until you do the step number 2. Step number 2, combine like terms and then enter your answer. So again, this problem has 2 questions, so I need y'all to write. When you go to the graphical equation, just type in number 1 and enter your answer. Insert, then go to number 2, enter your answer, and then press insert. So make sure you do this as 2 separate, 2 separate lines, 2 separate graphical equations. All right, so that's all the homework there is for this topic. Okay, that will conclude topic number 4. Thank you for watching.